All right, today we're diving into the fundamentals of computing and digital security. And our guide for this journey, it all comes from a really unique IT seminar that took place in Nairobi, one that was all about building the future of tech, one core concept at a time. So let's get into it. So let's set the scene. Picture this. It's 2019, and we're in Nairobi, the capital of Kenya. This is where a tech solutions company, Upgrade team, took part in a seminar designed to make a real difference for the tech scene in the region. So, what was going on? Well, this was an information technology seminar, but with a really important mission: to boost the tech skills of local institutions and their teams. This wasn't just about reading from a textbook, it was about giving people the real, practical knowledge they needed to build and protect their digital world. And the person leading the charge for Upgrade team? Engineer Abdelrahman Fathi Zalam. Now, his task was huge. He had to cover everything from the absolute basics of how a computer even turns on, all the way to the complex world of keeping our digital lives safe. We're going to follow right along with his curriculum. First things first, the anatomy of a computer. I mean, if you want to understand cybersecurity or how networks work, you have to start with the machine itself, right? We're going right back to the very building blocks of the tech that we literally use every single day. So what even is a computer? At its absolute core, it's an electronic device that takes in raw data, does something with it, processes it, and then gives us back something useful that we call information. It's that simple and that powerful. Now, every computer is kind of split into two essential parts. You've got the hardware, that's all the physical stuff you can actually pick up and touch, like your screen or your keyboard. A good way to think of it is as the body. And then you have the software. That's the set of instructions that tells the hardware what to do. That's the mind. Okay, let's quickly break down that hardware, the body. We've got the processor, or CPU, which is the brain. There's primary memory, which is like its short-term recall. Secondary storage is for the long-term memory, where you keep all your files. And finally, you have input and output devices. Basically, the way we talk to the machine and how it talks back to us. At the absolute center of everything is the CPU, the central processing unit. If the hardware is the body, the CPU is, without a doubt, the brain. This is where all the real thinking happens, executing billions of instructions every single second at a speed that's just hard to wrap your head around. So how does this brain think? Well, it's got three main parts. The control unit is like a traffic cop, directing all the operations. The arithmetic and logic unit, or ALU, is the math whiz that does all the calculations. And then you have the registers, which are like a super fast scratch pad for the CPU to hold data it needs, like right now. A computer's memory is fascinating because it's split in two. You've got RAM, which is temporary storage. You know when you have way too many tabs open and your computer starts to lag? That's your RAM filling up, but the moment you power it down, all that stuff is wiped clean. Then you've got ROM. That's permanent. It holds the core instructions the computer needs just to wake up, and it's locked in at the factory. So because RAM is temporary, we obviously need a place to keep our files safe for the long haul. That's where secondary storage, like hard drives, comes in. And of course, we need ways to interact with it all. Input devices like a keyboard and mouse let us give commands, and output devices like a monitor or speakers show us the results. Okay, so that's the body. Now for the mind, software. These are the programs, the instructions that actually bring the hardware to life. You've got system software like your operating system, which manages the whole machine. And then you have application software, which are the specific tools we use every day, like Word or Photoshop. So we have the machine. We get its body and its mind. But what's the whole point of it all? Well, it's to take all these raw, messy facts floating around and turn them into clear, useful insights. It's really a journey from data to knowledge. And this pipeline is a perfect way to visualize it. We start with just data, raw numbers, text, whatever. The computer then helps process and organize that into information, something that has structure and meaning. But it's when we analyze that information that it truly becomes knowledge. All this data has to be measured, right? A single bit is just a 1 or a 0, an on or an off switch. A byte, which is 8 of those bits, is about what you need for a single letter. But then things scale up incredibly fast. A megabyte is roughly 1 digital photo. A gigabyte is like a short HD movie. And a terabyte? Now you're talking about a whole library's worth of data. And of course, not all computers are built the same. At the base, we have the personal computers and workstations that most of us use.
Moving up, you get into mini computers and these powerful mainframes that run banks and big corporations. And then, at the very top of the food chain, you've got the supercomputers. These things are absolute beasts, built to solve the world's most complex problems.
So far, we've pretty much just talked about a single computer, but the real power today, the thing that changed everything, comes from connecting them all together. So let's zoom out from one machine to this global network that defines our world. And that global network is, you guessed it, the internet. It's the single largest communication platform ever built by humanity. It's this incredible web that connects billions of devices, putting an entire universe of information and services right at our fingertips. But, and this is a big but, with all of this connection, with all this data flying everywhere, a really critical question comes up. This connected world is amazing, but it's also filled with risks. So how in the world do we stay safe? And that brings us to the final and maybe the most crucial part of this whole seminar, our digital defense. It's not enough just to know how to use the technology, we absolutely have to know how to protect ourselves while we're using it. The main threat we all face are computer viruses. These are nasty little programs that are designed to do two things: copy themselves and cause damage, whether that's stealing your data or just wrecking your system. And they can spread through pretty much any connection, the internet, a simple USB drive, you name it. Two of our key pieces of defense are the router and the firewall. Think of the router as a traffic director for the internet, making sure all the data packets get to the right place. The firewall, on the other hand, is the security guard. It's the bouncer at the door, checking everything trying to get in or out and blocking anything that looks suspicious. Okay, but what about when you're out in public, like at a coffee shop, using their Wi-Fi? That's where a VPN, a virtual private network, is a total game changer. It basically creates a secure encrypted tunnel for your data to travel through, making you invisible to anyone who might be snooping on that public network. And so we come full circle, right back to that seminar in Nairobi. The goal wasn't just to explain what a computer is, but why it all matters. By building these fundamental skills, the real mission was to empower people to use technology not just effectively, but safely. And it leads us with a key takeaway. In a world completely built on code and connections, the most powerful tool you have is knowledge. So what will you do with it?